Hello, welcome back, and let's continue our discussion on machine learning. In the previous lectures, I covered and I explained very well what is machine learning and what is simple linear regression, and what's the difference between regression and classification. These things were taught in details. Now, if we have more than one feature, then if we have more than one feature, then the simple linear regression model, which you can see y is equal to b plus w1 x1, and here b is the intercept or bias, and w is the weight, and x is the feature on the independent variable. Now, if we have more than one feature, then we can't use a simple linear regression model, and therefore we need to utilize models with multiple features, also called multiple linear regression models. Here you can see that if you take the example of a car and you consider more than one feature such as engine displacement, acceleration, number of cylinders, horsepower. Okay, so these are more than one feature. In such case, we are going to use the multiple linear regression model, and you can see it below. The model will be written as follows. Here we're talking about the car, and it depends on displacement, acceleration, number of cylinders, and horsepower. Now let's come to the coding, and let's do the real things. Let's get a real data set and get ahead with our machine learning journey. So now you are familiar with how to import the libraries, which is the first step. So I'm not gonna type all the things again and again, so as it is already being taught to you. So I will just paste it directly. Okay, I have imported all the libraries and I run it. You need to run it so you don't face any unnecessary problems later. Now the next thing we need to do is upload our dataset. Now I will define my dataset, and I'm going to call the library NumPy, and here I'm going to use the command csv, and then here I will define, but since I have not uploaded my dataset yet, so I need to upload it, and this is my dataset. Okay, so I need to write its name clearly so that I don't get any mistake. And 50, you can also give it a path if you want to. It depends on you. If you don't want to upload it here, you can just give it a path and it is still fine. Now let me define my independent variable, dataset dot ilc, and then I will put clone, and I will call all the independent variable except the last column, which is my dependent variable. Then I'm going to define my independent variable, dataset dot, and here I will call all the independent variables again, all the rows, and dot values. Okay, now it will give me the last, the dependent variable. Now if I look at, let me just show you the data set. This is the data set. Okay, 50 startup companies and the money spent on research and administration and market and the stage given, the total profit is given at the end. So we are going to, it is many features, more than one obviously, at least 3 features are here, and we are gonna do some coding, decoding. Okay, and there is a lot of things that we need to do. So you can see that we have total 50 observations, which is good. So this is quite a lengthy data set. So now let's get ahead and see and discuss more. And you can see here that this column, this is just numbers, names, sorry, text, and machine learning just understand numbers, so we need to convert it. Okay, we're going to learn it later in the video. Now let's just print the first, three rows of X, and let's see what it gives us. And for that we need to use the command, and this is how we will print the first 3 rows of X to see what's going on. Okay, so this is the first 3 rows of our data set have been presented below. 1, 2, 3. Okay, and one important thing is that you have noticed the fourth column, 1, 2, 3, 4. It just takes New York, California, Florida, and machine learning models only understand numbers. So we must fix this. So stay tuned and let's see how can we fix this issue. So we need to do is encode categorical data. So encoding categorical data, and machine learning models are math equations. You need to understand it. Machine learning models are math equations. Okay, and they cannot compute New York. Okay, and we must convert text into numbers, but we can't just assign 0, 1, 2, 3, 4, because the model would think 2 is greater than 1, and implying New York is greater than Florida, which is false. So solution is encoding, one hot encoding. We turn one column of text into multiple columns of zeros and ones. Okay, so for that we need to go to scikit-learn dot compose, and here we need to import ColumnTransformer. Okay, and from scikit-learn dot pre-processing we need to import OneHotEncoder. Okay, let me just tell you something, and it is interesting. ColumnTransformer allows us to apply different transformation to specific columns, and OneHotEncoder turns categories into binary columns. Okay, so now let's me write city. Okay, and I'm gonna call the column transformer. I'll explain it in a while, don't worry about it. Let me just write it first. Column transformer. Okay, good. And then I'm going to use transformer and then I'm going to use, okay, so you can see that I typed it, okay, to save time. And here we have used the transformer. Okay, which transformer to use? We have used OneHotEncoder. Okay, and encoder is the name of step and which column we need to focus on. So here you can see that we have column 0, 1, 2, 3. So state we need to encode this one. So this is index 3, and remainder pass through. It means that leave the rest of the column as it is. Okay. One more important thing that you need to understand, that we fit and transform in one step, okay, which is good, but we must overwrite x with the result because the shape changes. Okay, so we need to overwrite this x now, okay, because it is a different shape and now it's going to have a different shape. Okay, and so we come here and we use the method transform, fit transform. So I'm gonna overwrite x, and it's gonna be np dot array and then ct dot fit dot slash transform x. This is how transformation is done. Now the value of x have been updated. Now let's print the new x so we can see what changes have been done. So let's say that we want to first 3 rows of encoded x, and we're gonna switch to next line, then x, capital X, and 3. If we run it and if there is no error, there is an error, okay, which is not a big issue. I'll fix it. Okay, since it is in the form of a list and we forget to put brackets here, so we need to put our brackets, and now you can see that after running all, the issue has been fixed. And look at here, now our codes have been modified. Now 0, 0, 1, and then the values of the 3 other independent variables. So stat, now we have New York. Okay, so this is 0, 0, 1. Okay, now if we have California, then it is 1, 0, 0, and now if we have Florida, then it is 0, 1, 0, and this pattern has been followed. Let's suppose if I do it for 5, you can see it here. One, 2, 3, 4, 0. So it means that 0, 0, 0, 1. So this is also this is also New York. Okay, so New York has this pattern 0, 0, 1. Okay, similarly if you have 4 or 5 or 6, then each will be assigned 1 and the remaining will be 0. So this is a pattern which is followed. So New York is represented as 001, okay, and then the next country is represented at 100, and the next is 010, because we have 3 countries, so there are going to be 3 numbers, 0, 0 and 1. Okay, so it is arranged this way. You need to avoid the dummy variable trap. The trap explained if a row is not California, so it's going to be 0, and not Florida, it's going to be 0, so it must be New York. Okay, so therefore the third dummy variable is perfectly predictable from the first two. This creates multicollinearity. The model's math breaks because features are highly correlated, and flattening variance and making coefficients unreliable. We must drop one of the dummy variable column. It doesn't matter which one. The drop column becomes the baseline, absorbed into the intercept B naught. Method 1 is manual dropping, okay, and method 2 is letting a scalar handle it. Let me just dive to you in short words what I learned. And okay, so don't waste much time. Okay, so now let's we take method 1. Let's do method 1. Okay, let's do method 1, which is manual method, manual dropping. And to do that we take all rows. Okay, so x take all rows, okay, and all columns starting from index 1 to the end. So how we write it? Starting from index 1 to the end. This drops the California column index. You can see it from here at California is 100. So this column is gone. Okay, the remaining will stay as it is. Now since California is gone, we now have column 0, which is Florida. Column 1 is New York. Column 2 is R&D. Column 3 is admin, and column 4 is marketing. Let me print it out for you so that you don't get confused. So let's just print the dataset X after, it must be capital, after widening the dummy variable trap. Then just go to the next line and print. Now let's just run it. Let me fix the brackets. I use curly brackets here. You can see that. Now you can see that we have 1, 2, 3, 4, 5 variables since California has been gone. Okay, and you can see here now, here we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 variables. Okay, 0, 0, 1, but since we have removed California, so we got now 1, 2, 3, 4, 5 variables. Okay, and the second trap is to letting sklearn handle it. However, you need to know that if you use Scikit-Learn's linear regression, it actually handles the trap automatically, and you don't technically need to draw up the column manually. However, for state models, which I will use later, you must drop it manually. So it is best practice to always drop it manually to be safe across all libraries. Now let's do splitting and training multiple linear regression model, and it is easy and same like the previous times we did it. All we need to do is from sklearn dot model selection, we have to import train test and split, and the split code is exactly same as simple linear regression model. Sklearn doesn't care how many columns X has, it just splits the rows. Okay, and this time we are going to use 20% for testing, so we are going to set the size as 0.2, and random state is going to be we'll set it 0 for reproducibility. So I'm gonna write xtrain and then xtest and then ytrain and ytest. Then you're gonna use the train test split method and use your data independent variable and set your test size as 0.2 and random state is going to be 0. Okay, now this is done. Now to check whether it is okay or not, let's just quickly paste it and run it to find the shape. You can see that we got the shape. We have 5 columns and xtest. So total we have 50 observations. 40 are gone to training and 10 are gone to 20% is gone to test. Okay, now the next thing we need to do is we need to import our model. We need to train the multiple linear regression model, and for that we need to import our model sklearn dot linear dot model. We import linear regression and we're gonna, let's say, call it regressor, define a variable and call it linear regression. Okay, and the next thing we need to do is that we are going to use the fit method, which learns the optimal b0, b1, b2, b3, b4, b5, since we have 5 features. And behind the scenes it uses OLS, ordinary least square, to minimize the sum of squared residuals across all dimensions spontaneously. So now we need to fit regressor dot fit, and we're going to use xtrain and ytrain. So now let's just quickly print model trained trend. Okay, so that we don't get an error. And yes, we did get an error, but we are gonna name regressor is not defined, so there is a error here. I need to add R here. Okay, forget. So take care of the spelling mistakes. Okay, now since we have successfully loaded our model now, and now let's get ahead and let's do more. Now let's do the predictions on test size. And then add our code, and you know that to do the prediction, all you need to do is define a variable y predict, and we are going to use our variable regressor dot predict, and here we are going to put our x test. Okay, and if we print y predict, we will get 20 outcomes. Again, spelling mistake. And let me just put R here and then run it, and there will be removed. You can see that we have 20 outcomes, 1 2 3 4 10 outcomes, and you can see here that yes, so we have 10 observations, so we are going to have 10 outcome here. Okay, now let's get ahead and learn more. Now let's do some more work. np dot set print options precision is equal to 2, and let me tell you what it does. At limit decimals to 2, and np concatenate, okay, this is another term that I will use below, and it allows us to stick arrays side by side, and I'm gonna reshape it as well. Okay, so that it turns the flat arrays into vertical columns. And let me just quickly do it so I understand what's going on. Let me just print it, okay, and then I'm going to use np dot concate, this is okay, and what it does, it allows us to stick arrays side by side. Okay, and then I'm going to use y predict dot reshape. Then I'm going to use the length of y predict and 1. Y test dot reshape len of y test and then 1, and most importantly I'm going to put the x is equal to 1. X is 1 means concatenate horizontally side by side. Make sure you put T here. Okay, then run it. You can see it here clearly what I did. Now it is in column form. So now it is clearly shown that this is the predicted column and this is the actual column. So these are the predicted values and these are the actual values. That's why here we have inserted the prediction and here we have inserted the test. Okay, and both are displayed here clearly. The problem with adjusted R squared in multiple linear regression model is that adding a new feature always increases R square, even if the feature is useless, and this makes you into thinking your model is performing better just because it is bigger, gives you bigger values of R square. So to fix this issue we use adjusted R squares, and what adjusted R square does, it penalizes you for inserting features that do not enhance the model significantly. I'm gonna add its formula for you and then we will proceed. So the formula is added here. 1 minus here R square is the R squared, and N is the number of observations or data points, and P is the number of predictors or features. So now let's apply this formula and find our adjusted R squared. Okay, now let's define our N. So our N is the number of rows and test set. So it is just xtest dot shape index 0, and this is our number of rows and test set. Now also let's define our number of columns or features. So it is phi and it is xtest dot shape and 1, which is our number of features, or you can also call it columns. Okay, so a regular R square from Scikit-Learn, we know that R2 is equal to, and you can define it as regressor. Okay, call your model and score, and here you have to put. So all we need to do is we need to call our xtest and we need to call our y test, and after that this is going to calculate our regular R square. So let me just write it here for you. So this will just calculate our regular R squared, and you need to remember something else as well. We can also calculate R squared through the method of import from Scikit-Learn that we did in the linear regression series. So do watch the previous video to understand how can you calculate it that way as well. Now the next thing is that we need to calculate adjusted R square. So we are interested in adjusted R square right now because we need to know okay, if if the value is too low or too big, things like that. So our adjusted R square, so let me just call a variable adjusted R2, let's call it R2, and this is the formula basically. So I'm gonna paste it here and I will just modify it here. You can see in the formula R square. Okay, so we have used R2 for the regular R square, so I'm going to replace it. Moreover, I don't need these brackets, and I think that the rest is fine. Now all I need to do is friend. I'm going to use the f string, and first I will I'm gonna go to the next line and I will calculate r squared score. Okay, then I'm gonna use the curly brackets, and here I'm gonna call my variable, which I represented as r2, and I will call for let's say 4 decimals, so I'm gonna use 4f. Okay, now the next thing I need to do is I also need to find my adjusted r square. So for that I'm gonna just use adjusted r squared let's say score, and same like that, but this time I'm gonna call the variable adjusted r2, and then I'm gonna use 4f so that 4 decimals are called. And after that I'm gonna call it. But before that I need to tell you something, that if adjusted r square is significantly lower than r square, then you have useless features in your model. Okay, so you need to take care of that. Now meanwhile, just run it, and let's see what happens if there are no errors. And you can see here that our r square score is 0.9347, and adjusted r square score is 0.8531. Now let's do the residual analysis. And let me tell you something, that residual analysis throwing our model is mathematically valid, and a high adjusted r square is great, but linear regression has a strict rule. The error, the difference between actual and predicted value must be random. So if there is a pattern in our errors, our model is broken. So let's calculate our errors, which we call residuals. Okay, so I'm gonna call a variable residuals. Okay, and here I'm gonna use the y test and minus the y predict. And you can see if you go back, you will understand that we have 10 values in y prediction. So residuals, we are going to have 10 values. Now we are gonna use plt dot scatter, since I want to scatter crop, and here I'm gonna use y predict. Okay, and I'm gonna use residuals, and I'm going to use the color red. And the next thing I need to do is I also need to draw a horizontal line as 0. For that I'm going to use the command plt dot a x h line. Okay, and here I'm gonna call y0. Okay, because I'm interested on the horizontal line, so obviously y will be 0. And I'm gonna use the color blue for this line, because the color red is also already used for the points. And I'm going to the line style, so I'm gonna use the style as I'm gonna use the dotted style. Okay, so this is going to be fine, I think. Okay, in case we'll see ahead if we get some problems. And I also need to define my x label. Okay, so my x label is going to be my predicted profit. Okay, predicted profit. And I also need to draw my y label, so plt dot y label, and my y label is going to be uh, residuals residuals and let's say errors. Okay, now the next thing I need to do is I'm gonna give it a title. Title is very important, so the plt dot title. And you also need to understand that we have already imported the matplotlib dot py plt at the start. Okay, so this is why I'm using plt again and again. So I'm gonna use my title, plt dot title, and here I'm gonna call it residual. Title is very important, residual float, and here I'm going to say checking for patterns. And as I said that there is not, if there is a sequence or things like that, then it means that there is something wrong in your model. Okay, it is broken model, not good. And the last thing I need to do is I'm gonna call plt.show to display my graph. Okay, so now how to understand the graph is I already explained it. Now let's just quickly run the code, and after that we will see what comes next. I think I got an error. Yeah, so let me fix the error. You need to understand the error. Okay, so X level. Okay, so we have made a spelling mistake, and you can see that I written LABLE. Okay, and it is LABEL. Okay, so you need to take care of the errors. To run again, and you can see that this time I didn't get an error. Okay, and you can see that, okay, this is my line, y is equal to 0, my horizontal line. And you can see, let me just zoom it out for you a little bit so you can see. Okay, you can see clearly that this is our predicted profit and this is our error, and total points 1 2 3 4 5 6 7 8 9 10. And why? Because if we go back here, okay, and come here, you can see that we have 10 values. Okay, 1 2 3 4, our predicted score. So the residual is just the difference between the predicted and the test score, and the y-test. And y-test is something that the model was not trained on, but we train it, we just give these values later to the model. These values were hidden, and we already discussed it in great length. So I hope that you got it, got the line and got the graph. Now let's get ahead and talk more. A while ago we find adjusted R square, and adjusted R square is for data scientists, but sometimes the CEO, the manager doesn't care about percentages, so they want to know how many dollars off is this prediction. So we use MAE and RMSE to answer this, and we already did this, but for here, for this model, we are gonna do it again. And let's just quickly import it from sklearn dot matrix. Okay, from here you're going to import it, and I'm going to import mean. You can also import the regular R square from here. Okay, we did it already, so this time I thought that I should do it in a different way so you understand it. Now mean squared error, and you can see that. Okay, so these two are enough. And RME, which is easy, we will do that, just a square root. So first we need to calculate the mean square error, and this is the average absolute differences between our prediction and the actual profit. And it tells us on average how many dollars are we up by, things like that. So let's call it MAE. Okay, so you use MAE is a variable. You can also name it whatever you want to. So I'm gonna call mean absolute error here, and here I'm gonna put my y-test. Okay, and I'm gonna put my predicted value, which is y-fred. Okay, y-fred predicted value. And the next thing I need to do is I also need to calculate my root mean square error, which is very important. Okay, so let's also use mean square error, MSE. Okay, and same like that, you need to call it mean square error. Okay, and then y-test, and then y predict. Okay, the next thing you need to do is you also need to find the root mean square error in RMCE. We call it RMCE. We did it in detail. Okay, we already did it in lengthy details, so just go back and watch the previous videos to understand it. So I'm gonna root mean square are just the square root of SQRT. It's the square root of MSE, and we are gonna just use here y test and y predict. Okay, and this is done. The next thing is that we need to do is the friending. I'm gonna use f string and MAE. Okay, MAE score. So let me just quickly use it. So it's gonna be in less than dollars. I'm gonna use the curly brackets. I'm gonna call the variable MAE, and I'm going to use two decimals to f. Okay. Similarly, you can also friend MSE. Okay, MSE score, and for that, same like that, you just have to use dollar sign if you want to, and you need to call the variable, and this time same like previous, I'm going to use two decimal. Okay, it depends on you how many decimals you prefer. The last thing I need to do is I'm gonna call my RMSE, root mean square error, and for this I'm gonna use again the dollar sign, and this time I'm gonna call my variable and then 2f. Okay, and now we can go to our business or whatever, and we can say that our model explain this variance and things like that on and on average our probability prediction will be up by roughly MAE amount. Okay, so things like that. So let me just run it, and I hope we don't get an error. So let's see. Okay, there is an error. Float object is not calculable. So let me just fix it. Okay, so since float object is not acceptable, so all we need to do is just remove it from here and just call run it, and it will gonna fix it. Okay, so you can see here our MAE score, MSE score, and RMSE score all are calculated.